So enough of the sales pitch. What does WPF actually look like? Here's a high-level view of the components involved. At the bottom, we have DirectX. Not strictly part of WPF, but it's how WPF gets pixels onto the screen. WPF uses the direct 3D pipeline to render everything. In the early days of WPF, this led to misrepresentation. Slightly misleadingly, people were saying that WPF was a 3D UI technology. And some of the industry's less diligent observers thought that this meant it was all about virtual reality-style user interfaces, with buttons floating in space, and with the end users with the upper body strength, and so on. And while there are some overtly 3D features in WPF, to focus on those is to miss the point. WPF is using the 3D hardware of your graphics card even when rendering 2D user interface. An awful lot of the so-called 3D hardware in a graphics card actually works in 2D for the very simple reason that screens are flat. The output has to be two-dimensional. In 3D rendering, 3D models must be flattened into 2 dimensions in order to be rendered. So WPF just hooks into the rendering pipeline at the point where the flattening has already occurred. Sat on top of the DirectX level is the lowest level component specific to WPF, the composition engine. This is sometimes called the MIL, the Media Integration Layer. It's so called because this is the component that is able to take the various different kinds of media, bitmaps, videos, scalable vector graphics, text, and so on, and render them all onto a single DirectX surface. This is where the visual aspects of the integration I was just talking about happen. Notice that the Media Integration Layer is unmanaged code. This may seem surprising, given that I said WPF was fundamentally a .NET API. Well, the reason the MIL lives in unmanaged code is that it has to talk to DirectX. And DirectX presents a fairly chatty API. You end up making lots of calls through COM interfaces when using DirectX. And DirectX assumes that COM calls are pretty cheap. And they are if you're writing unmanaged code. You can make millions of calls a second with a fairly minimal impact on CPU usage. Unfortunately, that's not true for .NET code. Using COM from .NET requires going through an interop layer. And attempting to make millions of calls a second across .NET's COM interop layer will burn a lot of CPU cycles. So the main purpose of the MIL is to reduce that interop overhead. It presents a fairly high-level API at the interop boundary, so it might only require one call into the MIL to ask it to render a complex shape, and then the MIL will make the hundreds or thousands of calls necessary into DirectX to realize that shape, thus amortizing the interop cost. The API presented by the composition engine is not documented today, so you might wonder why I'm even showing it at all. But as we'll see in the graphics chapter, it's important to know about this layering, even though you'll be working at the next level up. Sat on top of the MIL, we have 2 .NET components, Presentation Core.dll and Presentation Framework.dll. Presentation Core is more or less the public face of the media integration layer. It provides a .NET API that exposes the rendering services of the MIL. On top of this, we have the Presentation Framework. This provides higher level services. So the framework defines a concept of a control, for example. It implements layout, data binding, command handling, and so on. And the framework is where you spend most of your time as a WPF developer. You typically only work with the core parts of the API during graphics programming. The reason for this split is to make it possible to use the rendering services without the framework. For example, you could imagine a web browser that used WPF to render its content. It would have no use for WPF's layout and event handling because HTML has its own model for such things. So by splitting the core and framework into separate APIs, it will be possible for such a browser to be written and have it depend only on the core. Not that any such browser exists as far as I know, but it was a goal not to require people to use the full WPF framework feature set if they didn't want to. However, most of the interesting bits of WPF are in the framework, so that's mostly what we'll be looking at in this course.